Hi, I'm Jacob.
I'm Patrick. I'm Terry.
Today we will be presenting our smart wildfire detection system. Wildfires are becoming a more and more prevalent problem, especially in California. Our wildfire detection system aims to combat this growing issue. Our low-cost, low-maintenance system is intended to be used in rural areas and does not require a base station. Our system utilizes a network of units, each of which houses 3 sensors to detect fires: a camera, an infrared sensor, and a temperature sensor. Once a fire is detected, our system uses FM radio to alert firefighters.
For the camera module, we needed to know what the camera was looking at was a fire or not. To do this, we needed to build a machine learning program. To build this program, we used a TensorFlow library, which is an essential library needed to program machine learning programs, and the Inception v3 model. The Inception v3 model is a model designed by Google that is trained to detect many different things, including fires. To program this program, we took out the final layer of the Inception v3 model, which is the output layer, and put it on our own layer. We did this because the Inception v3 model can detect many different things, and we wanted to just detect fires. After doing this, we were able to achieve an accuracy of 99% using the Inception v3 model.
So besides the camera module, we also have many other places. So first is the power delivery. So essentially this can either be connected to a power line or get energy from solar panels. And then we have a battery bank for reserve power in case any of it goes out. After that, on the sensor, as Eric already talked about, is the camera module. And there's also an infrared sensor as well as the FM radio. So the infrared sensor is pretty simple. It just detects fires that are close in range, while the camera mostly goes for longer range distances. And once either of these two sensors have detected a fire, then the FM radio module will take this information and through software, it will convert this text into speech and send it over through the FM radio to a receiver. So in this case over here is like kind of an example of a laptop with a radio receiver over here, which can then receive the speech, the text-to-speech data, and then create or give firefighters a signal. From there, this FM radio can also be used on an Alexa or a drone. It's currently in development, so we don't have that programmed yet. But in the future, Alexa can then be used to tell the drones to go put out any fires, so the firefighters don't have to drive all the way over. Thank you.
Hi, this is our wildfire detection system. Here's the wiring can. So this is sending data. So now here is the solar panels. It powers this as well as possible outside power grids. Right? It goes into the battery pack just in case there is no power. Here is the camera, flame sensor, temperature sensor, and onboard FM radio. So it's giving a message of the date, the time, the station number, the temperature, and possible instructions. Currently, we have it mentioning to call someone. Right? And now the light will work. Thank you.
In conclusion, our Raspberry Pi-based forest fire detection system is very effective and efficient in rapidly detecting fires in all countries. Current methods rely on eyewitnesses to detect fires and relay alerts. However, our method is much more reliable and effective, which would heavily reduce response time and save a lot more lives. In the future, we will want to implement Alexa-activated drones, which will be able to put out fires on their own.
The process of developing the use of drones triggered by an Alexa to put out fires and wildfires nearby, and it could help firefighters go and put out the fires faster, and the response time should be a bit quicker. Thank you.